Good evening, MA Philosophy, Mpye-001. Block number 4, Predicate Logic. Unit number 1 is cleared. Second is Rule of Universal Instantiation and Generalization. Existential instantialization and generalization. And rules of quantifier equivalence. Objectives. One of the principal objectives of this unit is to bring to the fore the limit of Aristotelian logic. No, unit number 2 is proofs of rules of universal instantialization and generalization, existential instantialization and generalization, and rules of quantifier equivalence. The first objective of this unit is to emphasize the need to have a new set of rules. Before we apply these rules, a brief explanation of these rules is needed. Therefore, there is another important objective. This second objective is to provide a theoretical basis for the application of these rules. However, these rules only supplement the rules discussed in detail in the preceding unit. Hence, the third objective is to demonstrate how the integration of a new set of rules with uh, with with the rules with which we are already familiar is necessary. Thus, by the end of this unit, we should be able to have a basic understanding of the significance of quantifiers. Secondly, we must succeed in identifying the quantified statements. Finally, we must succeed in testing successfully the validity of arguments with the help of quantifiers. A quantifier is a tool with the help of which we will be in a position to measure the magnitude of the subject or proposition. What do we mean by magnitude? The term magnitude applies to any physical quantity which is measurable. In this particular case, the measurable physical quantity is things to which the preposition in question refers. If we translate this term to traditional mode, then it just signifies the concept of the distribution of terms. The difference, however, is that in traditional analysis, this concept turns out to be quite clumsy and ambiguous. Various synonymous words make matter further worse. The use of quantifiers in non-natural language resolves all these difficulties at one stroke. It is also possible to do away with mathematical interpretation of distribution of terms if we wish so. Further, this technique renders the application of distribution to the predicate terms superfluous. The significance of the rules of quantification must be understood against this background. There are four rules of quantification. They are as follows: universal instantiation, universal generalization, existential instantialization, and existential Generalization. The first two rules involve the quantifier, which is called universal quantifier, which has a definite application whenever an affirmative proposition contains words like all, every, each, etc. All propositions contains word like no, none, etc. Universal quantifier replaces all such words. This sort of economy also achieves simplicity. This is the distinct advantage of the use of quantifiers. On the other hand, whenever propositions irrespective of quality contains words like someone, many things, if you, etc. Existential quantifier is used in symbolic logic. These quantifiers are symbolized as follows: uh, a small bracket x or a small bracket opposite a x is the symbol for universal quantifier, and uh, a small bracket opposite ex is the symbol for existential quantifier. This symbolic representation of these quantifiers removes ambiguity in addition to achieve economy and simplicity. The difference between the instantialization and generalization rule with respect to both the quantifiers is that for universal quantifiers, UT allows the elimination of the universal quantifier, whereas UZ allows us to introduce a universal quantifiers, and similarly for existential quantifier, EI allows the elimination of an existential quantifiers, and EG allows us to introduce the same. Every quantifier has a certain range. The range of x and uh, and opposite ax is indefinite, whereas the range of opposite ex is definite in the sense that the latter case we are definite that there is at least one member, whereas in the former case we are not. Rules of quantification. In predicate calculus, the letter x signify individual variable. The the aforementioned four rules permit the transformation of non-compound into equivalent compound propositions, to which the rules of inference and equivalence are applicable. They also permit the transformation of compound propositions into equivalent non-compound propositions. These additional rules thus make it possible to construct formal proofs of validity for arguments whose validity depends upon the inner structure of some non-compound statements contained in those arguments. These rules stand in need of brief explanation. Universal instantialization (UI). This rule says that any substitution instance of a proposition function can be valid can be validity can be validly deduced for from a universal proposition. A universal proposition is true only when it has only true substitution instances. This is the necessary and sufficient condition for any true universal proposition. Therefore, any true substitution instance can be validly deduced from the respective universal proposition. A propositional function always consists of variable x. At time z also is used as a variable, and y has a definite role to play other than that of constant. Therefore, any instance which is a substitution for x is regarded as a constant, and letters from a through w are symbols for constants. These letters signify subject in traditional sense, and in modern sense an instance of a form. To obtain such an instance of a form, x is replaced by another Greek letter v, nu, which is another symbol uh, for an individual constant. It is also an example for universal instantialization, because the universal quantifier is ins- instantiated here. This rule is symbolically represented as follows. This rule requires a little elaboration. Let us replace v by a more familiar constant, say a and theta by f. When phi is inferred from x, fx, the quantifier x is dropped. The reason is that the universal quantifier has extension extension, whereas constant is restricted to one particular individual. Therefore, in this context, it is wrong to use universal quantifier. The use of UI allows such of those instances where we replace all variables bound by a universal quantifier with individual constant. Thus, x small bracket sx is equal to px small bracket will yield small bracket sa is equal to pa, where a is the constant used in place of the variable. The application of UI goes with a few stipulations. The quantifier x is x in x fx should not be within the range of a negation dash. It should not also be within the context within the extent of another quantifiers. The span of x in x fx must extend to the complete expression. A violation of any one of these limitations will lead to an incorrect utilization of UI. In other words, if we say that dash x fx implies dash fa, then it must be viewed as a wrong understanding of UI. We may use the UI rule in the following way: a, first remove the universal quantifier; b, next replace the resulting free variable by a constant. Universal generalization UG. This rule helps us to proceed to generalization after an arbitrary selection is made to substitute for x. In UG, arbitrary selection is very important because, as the name itself suggests, generalization always proceeds from individual instances. Arbitrary selection always means any, and there is no specific choice involved. In this sense, selection is random or arbitrary. The letter y is the symbol of arbitrary selection. This is the reason why y is not regarded as a constant. This process is called generalization because the conclusion is a universal proposition. The underlying principle is that what holds good in the case of any variable selected at random must hold good in all instances. In other words, the variable y is equivalent to saying any. If we recall the traditional rule of syllogism, universal conclusion allows from universal premises only. It only means that we need prior universal propositions. Let us club UI with this step. Then there then we are allowed to say that if universal proposition is true, then any variable selected at random must be true. Therefore, it must be understood that in this case the process is from universal to universal through an individual. When x replaces y, there is generalization. When universal quantifier describes describes the proposition, it becomes UG. The procedure is as follows: theta y upon uh, theta y upon is conclusion x theta x. In the above given rule, the letter y in theta y or fy stands for any arbitrarily selected individual. It is only a pseudonym and not the name of a particular individual. The letter y in UG is not a constant but an individual variable only, but it is different from x in the sense that it is an indefinite replacement of x. In UG, we substitute first all pseudonyms with variables and then bind them with universal quantifiers. We apply UG to the statement in the following manner: a first add the universal quantifiers; b then ensure that in the conclusion the variable is bound by this newly introduced universal quantifier. Existential instance is in instantiation EI. This rule is applicable when the proposition has existential quantifier, and in this case any symbol ranging from a through w is used as a substitute for the individual variable x. We can infer the truth of any substitution instance from existential quantification, because existential quantification is true only when there is at least one true substitution instances. However, this rule has a clause when it is applied to an argument. The constant say a which we use to substitute for x should not have occurred anywhere earlier in that argument. It only means that in the same argument, ei cannot be used twice when it is assumed that there is only one true substitution instance. This rule is represented as follows: uh, opposite x theta x upon theta v small b. This formula says that there is at least one or some unspecified number of members in the domain in question. Question have a certain property, say theta. The letter v is theta v stands for that unspecified number of members, and hence it is in a sense sort of pseudonym and not the name of any particular individual. Therefore, this may be called as existential pseudonym. It is necessary to adhere to certain stipulations while implementing this rule. In the first place, the formula opposite ex in ex theta x should not be within the range of negation theta dash. Secondly, opposite ex in ex theta x should not be within the extent of another quantifier. Thirdly, the quantifier ex opposite ex must cover the complete expression. B may use the rule ei in the statement in the following way. Number A, first remove the existential quantifier. B, next replace the resulting free variables with a constant. Rule number 2, existential generalization. This rule states from any true substitution instance of a propositional function, the existential qualification of that function can be validly deduced. Only then the existential qualification can become true. When the existential qualification is so deduced, the individual constant which appeared in earlier step is replaced by x in the conclusion. The unique feature of this rule is that though there is generalization, the conclusion continues to be existential. The rule is represented as follows: theta v upon conclusion opposite x theta x. In the rule, e.g., the letter v may be the name of a particular individual, or again a pseudonym. Uh, Opposite ex theta x states that there is at least one x such that x is theta. When we apply EG, we have to follow some conditions. Each happening of v in theta x must be substituted by x, and the scope of the opposite ex must extend to the entire expression. The method of application of EG is simple. A. Insert an existential quantifier. B. Ensure that at least one occurrence of the individual variable which we have generalized is bound by the newly introduced existential quantifiers. Earlier, it was stated that the ei should not have occurred earlier in any argument, but no explanation was given for this stipulation. We should know why there is this particular restriction on the use of ei. Suppose that a is the constant whose existence is definite. We are sure of the existence of A, but we are not sure whether there is any other constant. In an argument in an earlier step, a constant say A is regarded as B. The fact that A is B is not adequate enough to conclude in some other step that A is C. When there is no reference of these kind to C in the premise, since the logical constant A is used in existential mode, it is mandatory that EI should be used in the very first step of the proof. If if it occupies any other position, then it is a mistake. Now we can see that this unit is more practical, not theoretical. So you can see in new e-content app, uh, or we will discuss this in class. Thank you.